Hello everyone. So this will be another video for the three. So for this video, I'll be going to also show you how to absolutely do a deletion and insertion operation regarding with the FIFO principle, LIFO for insertion and key sequence, as well as for the deletion, the cases 1 and 2 and 3 for the leaf node, one child and two child, with respect to the in-order predecessor as well as the in-order successor operation. So now, regarding with that here, let's continue. Let's actually perform first the leaf node deletion. So for case number 1, for your deleting the leaf node, you can just easily delete that one automatically. So say for example, you will delete here. If you want to delete the number 5, then number 6. So that means to say you can automatically delete that one. So now, for example, for 5 and 6, for 6, you just delete that one. So that will be the answer for deletion of number 6 for deleting that one. So that's how you will do the deletion for the leaf node. So just delete the path as well. Now, for cases number 2 with one child, if you will be going to remove the number 5 right now, that means to say you will just only have to remove number 5. Here, you remove mo na si 5. And what will be the thing right there? You have to bring up the child of 5 into the place of 5. So that means to say 6 will be changed, makadto na si 6 sa babaw sa where si 5 nakalocate earlier. So that's how it worked for removing the one child in our tree. So what about for removing the two child? So say for example, you will do there, we want to delete the number 3, just like for example. So since in our two child class, there will be 2 options for that we can delete via in order predecessor and in order successor. But let me also give you first or show you how to do with an order predecessor. For an order predecessor, once you delete the number 3, you have to automatically remove number 3 and change the value of 3 into the largest value in the left sub 3. So what will be the left sub 3 value right there? Since the left sub 3 right there will be 10, so automatically si 10 ang ma-change sa 3 since siya ang ara sa left, wala na other cases right here. For example, si 10 may anak pa siya sa left nga 8, tapos may 15 pa siya, so si 15 ang piliun niya, supposedly, if may anak na siya nga amo na siya. However, now, since 10 will be the only value right there, so 10 will be changed into number 3 then. So once you delete the number 3, automatically, you will just bring up the number 10 right there. So you have to just bring there the number 10, and that's how it looks like once you will do the in order predecessor deletion operation. So that's how it looks like once you will delete the number 3. So another example right there. For example, if I will be going to delete the number 1 there, which is the root node. So since there will be a lot of child regarding on that, in order predecessor is still the same thing. So once we delete the number 1, automatically, what will be the largest element right there? So the number 6 will be the largest. So that means to say, once you delete the number 6, number 1, so it will be replaced by the number 6, since with that one, 6 is the largest value in our left sub 3, diba? So that's how it works. So that's how you will just do that. Now, how about for in order predecessor, successor, since we are done with an order predecessor that is removing and exchanging that value into the largest value into the left side. So for in order successor class, you will do right here. Once you delete the number 3, you will change that into the lowest value into your right sub 3. So what will be the lowest value in your right sub 3 for the number 3 will be the number 7. So automatic right there, number 3 will be deleted, and you will just change that into 7. Sorry, change that into 7, and then remove 3, replace that with 7, and then after replacing that into 7, you have to also okay, 1 second. Okay, bring up mo si 7, and then bring up mo si 8. Bring up mo si 9. So that's how it works in your thing right there. So you just have to bring up and just remove this one. So that's how it, if you are removing the number 3 right there. But if you will remove the root node, so that means to say the largest value right there will be the lowest value into the right sub 3 will be the 11. So that means to say 11 will be there if you are removing that one via in order successor. So that's how it works with in order successor. Because just always remember that one, that once you remove, it will be the lowest value in a right sub 3 as always, class. Now, okay, so what will be for the insertion? For insertion na naman, following with the FIFO, once you are what will be for the FIFO principle? You are inserting that at the rear point. For the rear point, it means that at the right, at the end of your queue, diba? Sa queue, if you are inserting that in a queue. So that means to say at the end of the sub list, diba? So if I want you to insert right there a specific number, for example, I want you to insert number 12 in any node. So you can insert that at the end of number 1, at the end of number 3, at the end of 7, at the end of 10, at the end of 8, 7, and so on. If you are being instructed to just insert that anywhere, but it depends on that one. But if I will ask you to insert that in a specific place, if I will ask you to insert the number 12 into the parent node of 2, so that means to say here ka ma-insert sang number 12. So that's how you will insert that if you are doing the FIFO principle at the rear point or at the last point of the sibling list. So that's how you will do it. And if you will ask you to insert number 13 doing the FIFO principle at the root node number, the parent node 13, so that means to say there you are expected to insert the number 13. So that's how it works then. If you are doing the FIFO principle. But if you are doing the LIFO principle, it will be different, class. Since of course you are expected to insert that at the front end of your sibling list, at the front end of your queues, for example. So at the front end, that will be here. So if you are expected to insert that anywhere, so that means to say you can insert that at here, basta left, and everything. So that's how it will work. So just only insert 11 at the root at the parent node number 8, for example. So that's actually so simple. So if 5, insert mo lang that. So that's how it works. But here, if sa 5 ka, so that means to say left si 12, tapos mahimo right si 5. So that's automatically understandable. That you have to also make sure that there will be a movement will really happen right there. So that's how it works for the insertion for the LIFO and FIFO principle. But if you are inserting class using the key sequence, it will be different. Since it will be sorted, it must be sorted. So say for example, if you will be going to insert number 12 at the root at the parent node 3, therefore dapat naka-sorted sila. Supposedly si 7 ari na di 10 kag si 12 ari sa pinakapunta, di ba? Supposedly. dapat arin na di. Kung sa key sequence. But key sequence will work sa ano na siya sa binary search tree usually. Kay sa mga arrange na nga nakasort na siya daan. But if you are doing the sort the that in one, for example, so that means to say in a key sequence 2, 3, 11, 12 will be the last child because 12 is greater than the other elements. So that's how you will do that. So that's actually very simple for delete and insertion. That's how it works. Thank you so much.